start the whole thing. Um, and we are going to, and I'll start already. If anything, anybody else come in, I mean, they can just jump in and follow through. So, robotics too. Um, welcome. Uh, it's just a couple of us, but like I say, I guess the other ones will hop in a minute. Today we're going to be having it over robotics. The second part, following the first video that we don't make about robotics, and today's topics is going to be a little longer. Today's topic is going to be um, a little recap, just a small little thing about what we done first time, end effectors, TCP, configuring the TCP, configuring orientation, configuring the payload and center of gravity, creating a program, controlling conveyors, safety settings, and this time this is for you, Peter. Last time he was asking, this is going a little bit more further into that and optimizing our program for it to be more efficient time-wise. Little recap. Last time we had it about sensors and conveyor belts. The majority of the project was getting to know a little bit about the robotic itself, and then put in some sensors and let two conveyors roll. Sensors were to help the robot to know when a product is in position for it to pick it and place it in place. And the conveyors were essential for the starting and stopping to let the product or the piece be rolled up to the sensor so the robot knows that there's a piece in place for him to pick in place. Before we go any further, there's four main group of end effectors. We have to deal with impactive ones. Those are the jaws and the adhesive jaws and claws, which physically grasps by direct impact upon the object. We got the ingressive ones. These are pins and needles, mostly used in the hospitals and textiles and carbon glass fiber handling. Restrictive ones, these have suction forces, but they have them in magnetic forces too, to pick up a little heavier products. And contagious ones, and these requiring direct contact for adhesion to take place, especially with gluing surfaces and freezing of certain products. Before we can start programming the robot, you will have to learn what the TCP is, which is stand for actually the tool center point. TCP can be found by finding the points of contact between the tool and the workpiece. Oh, sorry, workpiece. With other words, it is the center between the 2 points of contact. So when you look at this this arm, this gripper actually connected to the arm, you can see that there's a tool flange on it, whereas the gripper is connected. And when you see the gripper itself going down to the end of it, you will have the two parts that open and close. Those will be the points of contact. And in between the point of contact, you will find the TCP is always in between those 2 points of contact. Aside for the TCP, end effector does have a center of gravity. The center of gravity is the point of the tool where the weight of the tool is divided even on each side of the tool. So it's the balance point of your tool. That's important because if you want to work with it, you want it to be in center point for the right weight to be distributed in the right places when you're picking up a product. And the payload is the weight of the tool. Which is important because whenever you connect the gripper to a robot arm, that gripper has its own weight. and when it picks up a product or a piece, it will gain an extra weight from that piece that it's picking up too, and that's important too for the moving of that arm, and that we'll see that later on in the presentation. TCP, how to recognize it again is between the 2 point of contacts, and it's always the center of those two. For example, if we have a product, if you see left in the screen a cube, that TCP will be right in the middle of that cube. If you have the suction points, that TCP will be exactly again in the middle of the suction points. And the most, the one that difference in all of these is when you have a needle, and the TCP is of course then at the end point of that needle, for you to know. Configuring our TCP. The robot needs to know the position of the TCP relative to the flange, and to be able to pick up places of things and place them in other location that you want to. This is done by entering the 3 positions of the coordinates. And to do so, we can configure that TCP by going to the installation button. You select the installation button in the pendant, teaching pendant, and then you go to TCP, select the button in the left button menu, and then as you selected that button, you will see that there will be a screen opening with the tool center point information where you can put them in, and this is where actually you put the information of the TCP for it to know what is the position of that TCP. Now, it can be different. We can have 2 ways of doing this. First way is when the TCP is like straight directly on the z-axis and not offset on the x and y axis. Why is this important? Because in this position is only one information coordinates that you need to put in, and then you will know what and where to be. And to do so, it's very easy to get this one. It's just measuring it from the tool center flange all the way to the TCP point of that gripper. And that by measuring that distance, you can put this distance, and in this case is about 12.5 centimeter, and it's always in millimeter that you got to put it in the program. And that's actually the easiest ways to put it when it's straight on the z-axis. Let me see. And then you go to that and you fill out the amount of that TCP in your Z position in millimeters again. Now, when one second, if the TCP is offset of all the 3 axis, measuring is not an option. You cannot measuring at this point because it's gonna be it's not gonna be adequate, and your coordinates are gonna be all over the place, and the machine or the robot will go in different places and where it's supposed to be going. So in this case, we can use the TCP position wizard that the robot has in it. And with this wizard, you can let him program or calculate the TCP for you, and it'll automatically insert the coordinates for you. To do so, you have to put 4 reference points for him to calculate where the TCP is, and then he will put it in. So I have a little video here that will show. I'll put it a little And like I was saying, sorry, it was going a little fast. So now you go to that TCP wizard. Isn't that? It's not on the screen. Oh, sorry. Oh, it's saying, why don't it? A black screen. Give me 1 second. Okay. Let me see if I share another screen. Share a window. And that will be I think this one will be it. Come on. Okay. Oh no. Can you see it now?
Yeah.
Okay, cool. So when you are in that tool center point screen, this is the wizard button for the TCP calculation. So you select that TCP button and it'll change the screen for you on the right side of the teaching pendant, and you get 4 set points. Now these 4 set points are essential for your robot to know, because that's going to help him know where the coordinate of your TCP is. And then he's going to put them in. But you got to give them these set points one by one. It's just like teaching a little baby, like, okay, cool, now you got to put the left foot, and then, okay, cool, now it's the right foot. So by doing so, you select the set point 1, and all the 4 points got to be in different angles along same position. So now you put it in a position as is here, and then you acknowledge it by clicking OK. Again, go to set point 2 and put it in a different angle again on the same point, and acknowledge that point 2. Then you go to set point 3 and you do the same thing for 4 2. But then again, like I said, different angle. Set point 4 comes to the other side of it, and as you can see, all 4 of them are like on a star point from that angle point. After doing so, you gotta select the set button for it to be acknowledging that you are okay with the information. And what it does is it puts the information of the TCP position for you in that TCP coordinates points. Any questions so far?
No, I don't think so.
Okay, cool. Now the question is, can you guys see my PowerPoint? No, right? I gotta go back to it, don't I? Yeah. So I gotta go back to this. Give me 1 second. What I can do is Skype, share my screen, and go, where is it? And go back to our PowerPoint. Okay. And you should be able now to see that screen again. So that's what we did with the configuring for the first part of the TCP. Next is configuring the orientation of your robot. I'm going pretty fast through it. And to do so, sometimes the tool may be attached to a different angle, meaning that it is not parallel to the z-axis of the tool flange. In this case, the robot needs to know the orientation of the tool, but it's going to be calculated by the software, because you cannot do it by just measuring things, because otherwise it's going to be all over the place. To do so, you will have to Position the tool parallel with the z-axis of the base, and then select the wizard orientation. I kind of jump over one, but I will have a picture of the z-axis with the base in a minute too for you to see. But to do so in the wizard orientation, what you do is you select the second wizard button, which that is then for the orientation. You will select that one. It will change again the right side of the teaching panel. The screen will change. You will select now that you want the orientation to be chosen along with the base. Select the base and then select the set point. And then what he's going to do, he will calculate it automatically and then put the information for you in the orientation screen. And this is what I meant with putting the z-axis of the tool along with the z-axis of the base, because this is the base. By clicking the set point, it will get its coordinates, and you can select set, and it automatically put them in. With that point, with the orientation, you don't really have to put 4 points in. It just see that, okay, cool, it's parallel with the base form, so I know where the orientation is at the moment, and that's what he's going to use in the program. So that is for the orientation part. Now, the last part and the not least for the configurations part, and that's going to be the payload and the center of gravity. Payload is actually defined as the weight of the tool. So, the point of gravity is the point of the tool where the weight of the tool is divided even on each side of that tool. So the software can calculate this for you. Just click the gravity wizard, the center of gravity wizard button, and it will calculate that for you. Calculating it will be the same way that we done the positioning. You gotta have him you gotta give him 4 different positions for it to calculate it, and it's gonna be the same way. So you gotta teach him 4 different. You gotta put him in 4 different locations for it to acknowledge it and do his calculation, and then push them in through the system. During the teaching of the payload and center of gravity, it's very important for not to touch the tool nor the tool flange, because otherwise you're going to deviate. The machine can deviate in the calculating of this, and that is actually what it's using to calculate the payload and center of gravity. So it will be better to grab it by the wrist and not the flange. And like I said, we're going to use 4 points to calculate this. Again, like I said, it's going to be 4 positions. You gotta give him just like you give it to the first one, these 4 positions, and he will learn them along the way by clicking and accepting these, and he will automatically push them to the program. I have a little video that will show this one too. Oh, wait a minute. I think the video is not showing again. So let's change the screen again. Give me 1 minute. Share my desktop. Share. Okay. Can you see it? Okay. So now again, the screen is a little different in this situation, but it's the same. It's the same concept. So you're gonna select next. I think this one I made it a little slower because I was the other video was a little fast. So you select one, each one of them, and then set position, and then again you're gonna give him 4 position for it to record. And like I said, grab him by the wrist, not by the flange. So we put it in that position, and then we tell him, okay, this is where I want you to be. And then go to the next. It gives you an option to change the position too, but in this case you can just go to the next, set position again, and now in this time you're gonna come closest to the robot itself. Go to the pendant, acknowledge it. Third one, you're gonna go up if I'm not wrong for the third one. Yes. Just for him to know the angles where he's whenever he got the turn. And then last but not least, you're gonna give him the fourth one. Set position, and that one is straight on top of the arm. And acknowledge it. And the program will calculate it. When all four is in, you click next. It'll ask you for finish if that's the payload, and that is the center of gravity that you want him to use. You can click finish, and he will take these towards your input box for your center of gravity. Now, how do I go back to the PowerPoint? Go back to this, share the window. This will be this one. And now we're back at the PowerPoint if I'm not wrong. Okay. Click on here, otherwise it won't go. Creating program. Now, to create a program, we will have to know that in general that in the simplest way, the form a robot program consists of several waypoints and motions. Now you will say, okay, cool, what are waypoints and motions, Shanaida? Waypoints contains the coordinates that the robot TCP will move to, and the motion determines how the robot will move to that point. So again, we're going to give him a coordinate to move to somewhere, and then we have to tell him how we want him to move. Why is this important? Because if you are in a wider work area, it doesn't matter how you're getting towards the product, right? But if you have other robots and people walking around and it's more a busy work area, you want the robot to go move in a certain pattern and in a certain straight line, as straight as possible. So that's important when you're programming the robot. Now, to insert a motion and a waypoint, you can, when you have the teaching pendant, like we have over here, this is the main piece of that, you go into basic, and then you select the move button. But to select it, the first move, always make sure that the robot program name is highlighted. Otherwise, you're going to make another branch of it. So select your robot program name, and then click move button. As you click the move button, you see that there will be a drop down on it for the move J, and then attached to that move J comes a waypoint. Like I said, there's the motion and there's the waypoint. Now here you can see that this is saying that it's a move J. We have different kind of moves, like I said, basically three: move J, move L, and move P. And I will explain the three differences too. And like I said, when you go to the move screen in the command tab and you click on this drop down menu, you will see that there's indeed three moves that you have. And these are the three basic moves that they use with robots to program everything that they do. However, whatever you want to do, that's what they do. Now, each move. Oh, that went a little fast. We got the move J. When using a move J, also known as a joint motion, the robot moves to the TCP from one waypoint to another in a nonlinear move. What do I mean? This means that the robot don't care how it gets there, it just go to that position. And in this move motion, the robot moves the fastest. So a move J, just to have an example. Can I put this? Wait. Gotta go. Come on. Good. Here we go again. There we go. Okay, and you guys should be able to see the screen now, the movie? Yes. So, this is the move J. And as you can see, it just moved from one point to another. It don't really have no straight lines. It just be like, okay, I gotta go to that move. It just takes the fastest way home, with other words. And that's this simple, you move J. Now I won't switch to that screen back. I'll leave it to this. So then we have the move L, as I said. The move L is a linear motion that moves the TCP on a straight path from one waypoint to another. And this is more used for precise motions in confined spaces. So if I can close this one and open this one for you, you will see now that this is a move L. Now, as you can see in a move L, the robot kind of stops in each corner before it goes to the different location, to the different point. And it does it as straight as possible as it can. And this is good, like I said, to use in confined spaces. And then the third and not least position or move is the move P. This is the move process. It's another word how they call it. It's somewhat similar to the move L. Let me put that one on. This is the move P. But the only difference is that it's got a blend radius towards it. So as you can see, it don't really stop in the corners. It's just more like, because of the speed of the robot is constant, it just flow into the corners instead of stop and then start. So that's the difference between the three movements that we have. Now the move P is also used as actually the base to do a circle. So when you want to do a circle with the robots, that's actually what they combine. A lot of times they combine probably, if it is a confined space, they combine a move L and then put a move P. And then in that move P, they add a circle movement with it. And that's something that I have on too. Let me go back to the PowerPoint so I can show you guys that. Okay, and we are back at the presentation if I'm not wrong. Click on this. When using a move P, like I said, it's also possible to make a circle move. How to do that is you got to make sure that you have a move P selected first of all, and as you are in that move P, in the command tab again, left underneath that move, you gotta add circle move. And then once you click that circle move to add it in, it consists of actually two other waypoints that will be added to your movement in the program. And one of them is actually the via point, that's what they call it. And the second one is the end point. The via point is basically the start of your circle, and the end point is actually the end point of your circle. I do have not a video on that one. Sorry. I should have thought about this switching in screens, but desktop. Here we go. So now, as you can see, it starts with a straight line, and then it puts on the via point. It would to go towards the via point. At the end of that straight line, it just makes it kind of like a blend motion towards the via point and then the end point. And once it has that end point, you can turn it back into either a move L or a move J, which is then in this case is a move L because it moves straight to that end point. And that's how they make rotary motion then with the robots. Any questions until now? Okay, so with that all being said, now we got the basics. Now we know the TCPs and all those things to be said. We're going back to our program, what we done made before. And to do so, we are back here. Let me select this. Ah, man, I should have stayed in there, sorry. My bad. These three are going to be videos, so it's best for me to stay in here. Short videos, but they are desktop. Okay. Now, for the first three waypoints, it's very important to know, okay, cool. So now we have the first movement. If we're moving from the point where the robot is right now to that red point, what movement do you guys think is going to be the best way to do it and the fastest way to do it? The move J, move L, or move P? You want, which one is it? First. The move J? Okay, cool. Peter's saying move J. And that is good because actually you don't have nothing around you. So you can move however you want to move. And it's going to be the fastest way to do it too. So that's one to do. And indeed, like I said, that will be the route that the robot will choose. Now, to do so, we're going to go to the program. And again, make sure you select the program. Then go to your move, select your move. It will insert the waypoint and the move for you. It's already in move J. Now, to tell the robot from where to where you want it to move, you select your waypoint. And by selecting your waypoint, when this is selected, it will be highlighted blue. You can select set for you to tell him that you want him to move from point A to B. So now we're using waypoint J, like I said, and then we're moving from point A to point B, and then you acknowledge that. So now it knows that it's gonna pick up that type of motion. Oh, sorry. It's gonna pick up that type of motion, and by choosing that type of motion with combination of that movement. So now we got to go down to pick up the block, the piece that we have. Which move will be the best to choose in this case? P. You think P? Why do you think P? It goes straight from point to point. That's good. If you want to move it faster, you can move P and D. But in this line, it's because you're just going down to just pick up a little thing, and the easiest way is to move L. But indeed, it doesn't make no sense. It doesn't matter if you have a move P in there too, because like we say, a move P just go faster with that. And if you want to adjust the speed of the robot, that will help too. So because that move is a different move, it's good for you to select, again, go on the movement that you put in, and then click the move button. So it can put it nicely underneath that one. And because it's going to be a different type of move, this, like we say, is going to be a move L probably in this case, it's good to have them different. But there is, if you have two waypoints that are from the same type, you can put them two, and they follow each other up, you can put them behind each other. That won't be a problem. So let's see, we're going to get a move L, and then we got to select how he's going to go down. by selecting our waypoint. Sorry for that. Come on. Selecting our waypoint, set. And now we're moving it down towards our product. Acknowledge it, and now the robot will move to that point. The gripper, we're going to do the gripper in a minute, but then for the third piece, the third waypoint, you want to move back up. So in this case, the move L again, because that's the alternative of the first one to go up. So like I said before, what you can do is, because this one is the same kind of waypoint as the one that you just put it in, you can go straightly select the waypoint and add another waypoint in it, and then set that waypoint in, and then move it to where you want to move it by clicking set and adding it in. So that's our first part of the program. Any questions until now? Guys online?
So basically, sometimes you will be flexible
with the movements, yes.
movement, yeah.
Yes. That, like I said, it depends. It depends if you were in a wide area that you can work and use whatever waypoint you want. It doesn't matter then if you're moving L or P. But if you want to work towards having the speed of the robot, of the way, for the time that you're processing, sometimes move P will be the best choice, because it don't stop in that corner then. And the guys online, any question?
No questions.
Think of any, Steve.
Okay, cool. So those are the three first ones. Now, as we are going to finish the program, we are selecting for the next movement. We put another move in it. It's gonna be a move J2, because you're gonna move from that point to all the other side of the on the second conveyor. So in that situation, it doesn't matter if you're using move J, and that will be a faster one to do in this situation. Put it in place, acknowledge it, and now we got our fourth movement. And just like you did with waypoint 2 and 3, we're putting a move L now for waypoint 5 and 6, for it to drop it and then come back in position. So move L, select the waypoint, set it, and just go in position and acknowledge that. With working with these robots, every move you make, you gotta acknowledge, because otherwise it's gonna jump over a move, and then sometimes you'll be in the program, you'll be like, "Ooh, it's not doing something." It's because you didn't save that one. And that sometimes can be in the beginning when you're new with it. Sometimes you jump over one movement, and the program just jams sometimes, because it'll be like, okay, cool, I don't have that one. So that is actually our basic program, how to do it from the beginning to the end. And this third video is going to be how the program is really going to look like by all the waypoints that we don't put in. So this is our program actually. Come down. We were in motion and characters. And that's it for the program actually. Now, give me 1 second. I gotta switch back to this thing. I think you guys can see the PowerPoint now?
Mhm.
Yeah, okay. One thing is not good to do when you insert a motion inside another motion. It's called nesting. Some people work that way, but it's preferable not to do so because the tree will extend and keep on going to the right, and at some point you can't see it on the screen no more, and you don't know what you're doing no more. So the best thing to do is it's just common good practice how they do it in the robotics world. Just keep on select the move whenever you put a different kind of move. Select the move and put a new one underneath it that it can it can stay straight underneath each other, and just like I said, it's just a good practice of working. Interaction with external devices. Now, there are also important comments are also important on robots because this is the way the robot waits and reacts to inputs from external devices such as sensors and other devices that we can put on it, cameras and whatever else you want to put on it. The most common ones commands are the set command. It can be either digital or analog output to a specific value, or a wait command. And with the wait command, you just make the robot stop and wait for something to happen before it keeps on moving, or wait to give the gripper the chance to open and close to drop or pick the product that you're going to work with. Command wait. Now, we're going to update the program to let the robot wait whenever it comes after that waypoint 1, because when it gets there, you want it to wait for the sensor to be in place actually, so it knows then that, okay, cool, there's a product in line that I can pick up, so now I can go pick it up. So we're going to pick up our waypoint 1, and then we're going to select wait, and by selecting that wait, it's going to add, as you can see here, a wait command underneath that waypoint 1, and it's going to give you an option on the command tab. Again, you're going to see the wait properties that you can select. In this situation, it would be the best way to select, because we can tell him, let's wait for 1 second. We can tell him, let's wait for an input, or let's wait for a digital input, or let's wait for a variable. In this case, it's best for us to do it for a digital input because we're working with a sensor. So we're connecting the sensor to the robot now. We're telling him, okay, cool, I want you to wait after that waypoint. Whenever you move to that waypoint, when you're done with that movement, wait for the sensor to activate for you to drop and pick up our product. So you select then wait for the digital input, then you select that drop down menu, and then select your sensor, which is sensor 1. After selecting your sensor 1, you're going to tell him, okay, cool, I want to wait until that sensor goes high, which is activate. So you want to wait for that sensor to activate, for the sensor to go. And this will be the difference in the screens then that you're going to see. I put 2 different ones. Let me do this, and then I'll make it bigger. So this is when you put the wait command in. And this is after you are telling him what he's supposed to wait for. So he's going to tell you what I'm waiting for in that position too. So it's not just the wait command that tells you, okay, cool, he's waiting, but what is he waiting for? And that is good about these commands. It tells you a little bit about the information of that. And in that case, it will wait before it goes drop down. I do have another video coming for that too. And that will be this one. It will just wait until that sensor activates for it to go down. That's all that it does. Any questions about that? I don't think it speaks for itself. No? Okay. Then we're going to go to the set command. Okay. Set command. To insert a set command, we can set one after that waypoint 2 in the program tree, because we want him to um, to be put for the gripper to be activated, because you need to activate that gripper once that robot arm comes down, and that's what you do with a set command. And to do so, like I said, you select that waypoint and then click set, and then it will put a set underneath that waypoint for you. Again, you're gonna get the same thing like the timer, like the wait command. You're gonna get some properties, some choices for you to choose. And we're gonna do it set digital output, because we wanted to tell the gripper to activate. Then you're gonna select the gripper in the drop down menu, and then you put the gripper in high. So now you're telling him, whenever you finish with that waypoint, I want you to make the gripper close, with other words. Now the command set goes a little longer. I got the same screen as I had for the timer, the wait. And as you can see, once you put it in, it's a set, but after you set it on, it's going to be telling you that it's a set the gripper on. So activate the gripper at that moment. Payload set. Oh yeah, right on time. As we are grabbing a workpiece, the payload of the effector will change. That's of course because it's going to be more weight towards that, so it's going to be heavier. This can be updated by selecting set the total payload to 2 in that field. So in that set command screen, in that set screen, you will get choice here to select it, set the total payload. So once you select it, you can put the total weight of the gripper after he grabs that product. Why you want to do this? Because now the robot is going to be expecting for that product. Let's say our gripper is actually 0.6 kilograms and the product is 3 kilograms. So after the gripper close, the machine, the robot is going to be expecting, okay, cool, I just need to pull 0.6 kilograms. But when that weight is more than he was expecting, he's going to stop. He's going to be like, yo, I don't know. No. This is not what I'm having in my system. This weight is heavier than I'm supposed to pick up. So I'm just going to stop. He's not going to do nothing else. So you do need to change for each time that you import or that you are putting a gripper, or that, let's say each time that you are activating a gripper, you got to make sure that you activate that weight too, and make the weight proper towards the weight of the gripper plus the weight of the product that you're picking up, for it to accept it and keep on working. Otherwise, it's going to stop and start. You're going to be looking at you and him. He's going to be looking at you like, I don't know what you want me to do, but this is not going to work. It takes a little time too for the gripper to grab. So for you to have it work optimal, it's best to put a wait time for the machine to know that, okay, cool, whenever that is working on, let me wait for a couple of seconds before I go to the next waypoint. So now we don't set the gripper on. We're gonna put a wait in. Again, in this situation, we select the gripper, and then we select this set option, and then select wait, and it'll put the weight underneath that gripper. And in this time, in this example, we just want him to wait for 1 second. So you select wait, and then 1 second, 1.0, and it will do it. Now, jumping again, guys. I'm sorry. I'm trying to make it as visible as possible. So in this moment, you see, it picks up the grip, it picks up the gripper, and then it goes up. That's just that one for it to move over to our other position. Now, with that information, now what you want to do is you want to put the same thing, because now we done the part of picking up. We can do the part of dropping down, that are letting that product loose in the box. And that's the second part. When you drop when you put that piece down in the box, you want the gripper to open and be able to let loose. So what you're going to do is, after that move J, you want the robot to wait for that second sensor to activate. So we're going to put a wait, and then for that wait, we're going to do this just like we did for the first sensor. We're going to put that sensor activation and then the timer. And then actually after waypoint 6, you want to put a set, because then you want the gripper to let it loose. And then after the set, you want it to wait for it to open and let the piece up. So now we're going to update each one of them. Like I said, the first wait is going to be for him to wait for the sensor, for second sensor to activate, and then go high. And then that set behind the fifth waypoint is going to show you then now. So only if that goes on, then the robot will drop it, will go down. Let me put it that way. Then when you click the set, we're going to set it to deactivate our gripper. And this time it's going to stay in low, because you want the gripper to open. And I think I put it in to show that if you do not change the payload, the robot will stop, because again, it's going to be expecting a heavier weight going up than what's on it. So let me show you. So when it goes down and it opens up, you see what it does? It's be like, okay, cool. It's not gonna work optimal because you didn't let him wait, first of all. Select the wait. Let's put it in 1 second again, just for him to have enough time to open the gripper and be okay with it. And as you can see now, when it goes down, it opens it nicely, and it don't drop the piece in the box. Now, it has a protective stop because we didn't adjust that weight of the gripper. It will stop and tell you that there's something. Check the payload, check center of gravity, because something is not wrong, something's not right. So what you got to do is you got to enable your robot, go to your set gripper off again, because you're letting him lose that piece. You need to put the weight of your gripper back in, because otherwise it's going to keep thinking that it's got 3.6 kilo to work with, but it's going to be using more power than it's supposed to use. And then when it goes off, it's going to all the way up. You don't want that. And that's our last part of the project, of the update. We only got 2 more sheets and we're going to be done pretty much in time. Okay, so again, switch back. Sorry for this again. Okay, and now we get back to the PowerPoint. Controlling conveyors, that's the next thing. Now, as we all know, the conveyors need to be having their own parallel program running, because they be running on their own. They be starting and stopping, and it's actually a second robot program that you put parallel to the regular program, and that's what they call a thread. Um, to do so, you can, as you can see here in the program, you can go to Advanced and then select the thread button. It will put a thread 1 underneath it. So with thread 1, we're going to dedicate that thread towards the conveyor 1 because we want that thread to be starting and stopping that conveyor whenever that we want the conveyor to be running whenever the sensor is not activated, and when the sensor is activated, we want that conveyor to stop. Otherwise, the product is going to keep running on the line, and the robot ain't never going to be able to pick it up. By doing so, we can go back to basics then, keep the thread 1 selected, and then we're going to put a set on it. So again, because now you are waiting for that sensor to activate, so you're using a set command. So we're selecting the set command, and then we put in the conveyor 1. Whenever the conveyor 1 is high, you want the conveyor itself to stop, to basically the wait for the sensor. So the sensor is high, so you're waiting. The conveyor is basically on, like I said, it's running, and you're gonna wait until the sensor is high, and then once the sensor is high, that is gonna stop your conveyor. And then again, you're gonna put another set button. Set conveyor 1 to off. So basically, again, when the thread starts, start the conveyor. Whenever this goes on, stop the conveyor. So it's reading it really line for line and going down. Then we put another wait sensor to go low, and then whenever the sensor goes low, we're going to put a script on it. So to put a script on it, you select that wait sensor, select your script, because that's not what we done before. We select the script, and it'll open this command tab for you in the script. You're going to select this, and by selecting that field, it opens the tab for you to type in. So what you're going to do is you're going to type synchronize, and then open and close behind it. So what it's going to do is after that motion, it will be able to restart itself. So what it does is now it's a loop. You don't create a loop, with other words. So we're starting the conveyor. We wait until sensor 1 goes high. When it's high, we stop the conveyor, and then we wait until the sensor goes low. And then once the sensor goes low, hey, go back on top. So start the conveyor back again. So that's what it's that's what it does. Another thing that will come in the next one will be a variable. A variable is you should think about it in this case as a container that can store both text and numbers, because you can put in if something is true or in something is false. Why I'm putting this out there? Because this part will work great. It will work great if it is this setup for the first conveyor. But when you are on the second conveyor, you're gonna have to wait for something to activate that conveyor, because it's got to wait for the sensor it's got to wait for a command of the robot to be like, okay, cool, now I can start. And that's where you put a variable and say that, okay, cool, whenever it is true or whenever it is false, do whatever you want it to be doing. Each variable has a unique name, as we already know, and which you can use as a label. Now I do have these two. Give me 1 second to change again. And hello, you guys can see it? Okay, so now we done put the program in with a thread, and we're gonna see what it's gonna do. So now it's gonna stop, wait for that conveyor to run. Whenever the sensor is on, it's gonna stop. Pick a robot. Whenever that sensor is on, you see the next product is gonna come and wait for it. It's gonna stop and stay there, wait until the robot picks it up for him to start again. And that's our first conveyor. And then when we add and update the second conveyor, like I said, again, what we gotta do is we're gonna make a variable. And where we're gonna make it is gonna be after that last waypoint. So after that waypoint, when that robot is turned to the line, be like, okay, cool, I'm ready to do what I need to do. So I need to set a variable for that, so we can drive the second conveyor with it. So in the command, we assign, we go to program and we assign a second thread. Actually, before that, we can set a initial variable. And with that, we're gonna send the inbox, and in that case, we're gonna make it false. Because why we are making it false is, like I said before, whenever that waypoint, that last waypoint is done of the robot, you want the robot to let him know that, okay, cool, that inbox, I call it inbox, but it's just that that variable is true. So once that variable is true, you can start you can do whatever you need to do with your second conveyor. That's what it is. Now for the second conveyor, as you see, we made a second thread. Like I said, you go to advanced thread and then put it in, and then put your set, weight, everything that you need. And basically, most of it is going to work the same thing as thread 1. But as you can see, after that wait, it's going to wait. After that, after this set, you're going to go to the true of that inbox, let him do what it needs to be doing, and then go back. Whenever it goes back false, which is at the end of that part of your robot, it'll keep on doing what it needs to be doing. So I took a little time with this one because I know. Yeah. So we set up the set. In this case, we're gonna work set conveyor 2 and not conveyor 1 to high. So whenever conveyor 2 is on, we're gonna wait for sensor 2 in this case to activate. And once it activates, we want that conveyor 2 goes off. Once that conveyor 2 goes off, we're gonna wait for the robot to give us a signal that he's ready with the dropping of that box, of that piece. And after that signal becomes false, we can start that conveyor back again until that sorry sorry sensor goes back to low. Actually, let's play it. So now we have the same thing that we did for 1. It's gonna wait for the sensor to activate, put the box down, and it's gonna wait until that inbox is done, which is actually, you can put it on that slider that's coming up and down, and then you keep on rotating that machine. Any questions so far? No? Okay. We're getting to the end, so bear with me over here. Let's see. Let's go back to the PowerPoint. Okay. Now, safety settings. The robot has its own safety stop. That's normal. Whenever the robot has or feels that it's too much resistance coming towards it, it will automatically stop. That's programming these robots already. But there are more things that can be added to the system that could help us have a safer work area. For example, we can add a safety scanner. Why a safety scanner? Because if the scanner sees anything in the neighborhood, it can either stop or reduce the speed of the robot so accidents will not happen, or if it happens, it won't bump into you so hard. Or put an externally emergency stop. Everybody knows that if it is something that's heavy and it's working with big pieces of products or heavy pellets, emergency stops will be ideal to do it, because then you stop the whole process, and then you can always restart it. Safeguard reset button and safety boundaries are ideal to work with too, because if you have 3 robots close to each other, you don't want them to cross in each other work area. So then we use the safe boundaries. And we got a tool spear, and a tool spear is nothing more than a restricted area that you put around the piece for the piece not to cross that safety boundary too. But we'll see that too in a minute. For that safety, for the front risk reduction, these 3, I put them straight into the video so we can put them in and just take a look at them. And it will be clearer for you to see too. So, like I said, bear with me guys, we're almost done. So, for the front risk reduction, what you do in this case is we put in a camera. That's the first thing you can do for safety. And for the camera setup, we can put the camera in a configurable input, so you can configure your inputs then towards whenever that camera activates what you want it to do. A lot of times there will be a password on the screen for that before you can even get to the other safety things. So you go to the safety page, go to then the IO, and you gotta unlock that that screen first before you can even get to the settings. So we put that scanner on config 1, on config 01. So we're gonna select the drop down, and in this case we're gonna put it as first as the reduced mode. And the reduced mode don't do nothing else, but whenever somebody gets in that scanning area, it just slows the machine down. That's all what it does. It's a little safety, but it's not all the way safe, but there's more things that you can put in it. These are just information that the machine is telling you that, okay, cool, these are the power, these are the things from the stopping time and everything that's going to be in there. If you don't want to work with them, you can always change them, but majority of the time, those are the default measurements that you have. Now, as you can see, if somebody come in the work area of the robot, it will slow down. And as soon as this person steps back out, the robot will get back to its normal speed and keep on moving where it's moving. So that is actually your safety scanner work. Now, to make the robot really stop when somebody gets in the scanner, it's better to use the safety inputs and outputs, because these inputs and outputs are not configurable. They are just, as soon as something gets in its way, it will stop the whole thing. And this is actually where you can put your emergency stop too. So in this case, what we're going to do is we're going to take the safety scanner from the configurable inputs, and we're going to connect it to the second um, safety for the robot. So we're going to take the plugs, take the pins out, and then just move the cable towards there. And then, of course, you got to go back to the safety screen and take that reduced mode setting off and put it as unidentified again, so it won't see that, just to make sure that it's back to normal. So this back to unassigned, because it's not assigned no more. You're not using those configurable inputs. And then now, as he picks up the piece and somebody walks into you will see that the machine will stop automatically. So like I said, there's where the location where you can put your stop button to, emergency stop. As soon as the person moves back, it will start where it stopped. That's the good thing about the safety scanner. But if you have a emergency stop button, you will have to reset the whole program for it to start again, because it won't start at the stop that it was. Now, to put a safeguard reset button, we're gonna connect one reset button to the configure and input again, and we're gonna go to the same location because that's where we put it. And in this we're gonna put, in this choice, we're gonna put the safeguard reset because it's a reset button, and then apply and restart. It'll tell you, okay, cool, what are my limits, what are my momentum, stopping time, distance, and everything. And now, whenever somebody come in, and then move out, you will have to press that reset button for it to start. So in this case, it didn't really automatically start. So now we really have to reset the button for the machine to start. This is just to make double assurance that, okay, cool, if somebody's not in there, because you already have some fools that be, okay, cool, they don't trip maybe in that area, fell down, and then they need to get up, and then their head gets out of the secure area, and then before you know it, the machine starts running again, and then they when they stand up, their back will still be it, and then they get hit. So that would be ideal to put a reset button on it. Now, like I said, for emergency stops, we can use the first locations to connect it. I mean, you always want that as a primary input to it. Emergency stop, we're going to connect it. And now it doesn't matter where you are in this situation. As soon as you drop and press the emergency stop, the machine will just stop, just like a normal e-stop. But for it to restart, as you can see, it will give you a robot emergency stop has been activated, and you gotta go to the initialization screen for it to reset the whole robot. And that's how you put so now we had the safety scanner, the externally emergency stop besides the stop that the robot has itself already, and the safeguard reset button. So now we're going to do the safety boundaries in the tool sphere.
Yeah, but if you press reset stop button, then you will reset it. The robot will drop the box on the place where it was stopped.
No, if you press the reset button, you
No,
say?
if you press the stop,
Mm-hmm.
and then after reset,
Mm-hmm.
it will release the grip and went to the.
It will, yes, it will reset the whole thing. The whole robot will go. It will go to position 0. That's what it will go. So that a lot of times when you want to do an emergency stop, and if you did an emergency stop, it's ideal for you to make sure that something is there to catch that product, because it's gonna open and let that product just go, and then for it to go to its starting point again. Um, Boundary safeguard. Now, as you can see here, did I press the plate? Yes. We are working now with an area, which is that purple area that you don't want the robot to go into when it's turning towards its back. How you do this? You gotta set up certain areas for him to be able to know that no, I'm not allowed to go past this border. And to do so, we go to futures, and we choose in this case a point because we're just moving that screen. You can put a lane, you can put three methods. You can put a whole plane, which will cover a whole wall if you want to. You can put a line, which you can draw the line where you want him to be stopping. If he passes that line, then you want him to stop. Or you can put a point, and when the point, it will be having a whole rows. It will have a whole piece for you, and you just select where you want that point to be, and it will block everything around that point then. And in this case, we're going to work with a point. So again, we select the point, put it in. Again, it's in a different parallel program. Again, it's a feature in the program. And then you're going to go to set point. Then you're going to tell him, okay, cool, I want you to not be able to pass the backside of the robot. So what you do, you turn that TCP towards the part that you don't want him to go crossing in. So as you can see, we put that point there, we acknowledge it, and now it knows that, okay, cool, this is the area that I'm not allowed to cross, but you haven't connected the area yet to the program, so we need to do that now. Oh, sorry. Acknowledge it. And to do so, we go to safety, we go to planes, and then you move to the add plane. You select add plane, and it automatically add that plane for you because that's the only one you have. And it will know that, okay, cool, this is what I know that I'm not supposed to pass, but okay, cool, what do you don't want me to pass? So you're telling him, I don't want you to pass this point that I just made. This is that screen, that purple screen that we just passed. Now, along this plane selection, this point selection, this feature selection, you get two restrictions on it. You get the normal restriction, and the normal restriction is just whenever the robot is in its normal drive. If it passed that line in its normal drive, then it will stop. You have the reduced one. The reduced one is whenever somebody is, remember when somebody gets into the safety scanner, it will reduce the speed. So if you want it to be stopping, if it is in its reduced speed, you can select that one, or you can do both, or you can trigger a reduced mode that you install. But that's not the case. In this situation, we're just going to put both. It doesn't matter if he's coming with the normal speed or in a reduced speed. We want him to stop as soon as the base or the TCP cross that line. So we're going to select the both. I'm sorry, I was giving myself a little time to explain that part. And then apply and restart. It always double asks you, like, okay, cool, you really wanted to do that? Okay, let's do it. So now that part is in it. So the machine will stop as soon as the TCP or the base of the robot or other parts of it to cross that part. Now, the third part was the tool. And now in the tool sphere, you can see that a lot of times when the machine is turning, it's not really the TCP that's crossing that line. It's the product that is carrying that's crossing that line. So in this case, we don't want that product to cross. So that's why we're gonna put a tool spear around it. So nothing, as you can see, you see the product is more in it than the gripper itself. To do so, like I say, we can put a tool sphere on around that product. That will be like, okay, cool. As soon as it's like a certain amount of millimeter far from that TCP point, you need to stop too. For that, we're gonna go to tool position. We're gonna go add tool, and now you can change the radius. Let's change it to 200. The maximum is 300. I just put 200, and it will form a you will see yellow, and that's that ball around it. As soon as the edge of that ball crosses that line, the machine will stop. And that's it. So your product won't cross, your robot won't cross. So now you know that that safe area is protective, and everything that's behind that robot after that wall will not get touched by it. Not supposed to get touched. If something happens, still goes, then you got a problem. Any questions, gentlemen? Yes.
So let's say the boxes could be, because all the production is not like gram to gram weight, so you should have the gap for the box dimensions, for example, or for the box weight, and it could be like up to like half kilogram difference, could be, it depends what you're making. So is any like settings for this like deviations points or something?
That's a good question. That is being determined by the type of gripper that you're making. Mm-hmm. So whenever you have like this gripper, it won't be able to pick a big box. So that's why it goes all the way to that setting. But if you have a big gripper, it will give you more area to work with.
Yeah, but same box could be like, let's say you stuck in there,
like 6, 7, 8 pieces, and for some reason like operator or somebody put the 10 pieces of product inside, so the box will be like
bigger than it's supposed to.
Yeah, up to 10% of the weight, for example. So there's any like adjustment for the weight, because the parameter you showed, it was just like 3.6 kilograms. So how probably should be somewhere like where you have to manage this the weight, right?
And that's
one thing. There's another one thing. It's another thing that's going to activate
if a operator puts more box than it's supposed to be in there. Mind you, they don't work with the program. So the program is already set up to, okay, cool. Whenever he grips, this is the amount of weight. It is normally 7 boxes, and those 7 boxes, I'm just saying 10 kilograms. If you got 10 boxes, it's over 10. That machine's gonna stop
right away.
It's not gonna go up. That's first. Second is that if you have something that is still
done, picked up, that the 10 boxes, the machine will not operate in the same speed neither. You will notice that something's wrong with it.
Because now it's working with a
weight
that you didn't set him to be at. So it will tell you that something is wrong. That is something else that's another step that you can put, okay, cool, as soon as you have, if you're normally supposed to be having 10
kilograms and you have 10.5,
alarm should go up. Those are the alarm topics then. So then we
go into another thing that you
put along with the robot. Those are things that you can put for him
to know that, okay, cool,
the weight is over, and he knows that he's not supposed to pick it up
because he knows that that's not the setting in his program. But still, he needs to send a
message to you that something is going on
that's not supposed
to be going. And if he picks it up, that is because it's 10.2 kilograms maybe, or a little bit
more.
The speed that it's working with is not going to be the same.
Because again,
it is programmed to work at a certain speed
with a certain amount of kilograms.
That's why you set all those things previous to the program.
Okay.
Yes?
Because usually sometimes like for conveyors or for other things, you can put the gap. So let's say the box could be from like 10 up to 11 kilograms. It's fine. Everything over everything below, something not right with
Yes.
the product.
And
And
that's the
that's the
same
same
thing
thing
that
that
you
you
can
can
do
do
with
with
input
input
and
and
alarm.
alarm.
As soon
As
as
soon
it
as it
passes
passes
that
that
10.5, you
10.5,
want
you
it to
want it
go
to
off
go off
because
So
it's
it's configuring through with alarm, right?
yes, you
yes, you
can do
can do
that too.
that too.
That's
Okay.
That's
another.
another.
That's
That's
further
further
down.
down.
As you
As you
keep on
keep on
going
going
into
into
knowing
knowing
more
more
things
things
about them,
about them,
there's so
there's so
many
many
things you
things
can
you
put
can
on
put
there.
on there.
Yes.
Yes.
Any more
Any more
questions from
questions
the
from the
other
other
guys?
guys?
No.
No.
I got
I got
one
one.
last thing.
No.
Hey,
Yes.
Yes.
hey, Shanita, I could barely make you out, but I think you asked if we had any questions.
Yes.
Yes.
No, I think I'm good right now.
Okay.
Okay.
I
I
have
have
one
one
last
last
thing
thing
and
and
then
then
we'll
we'll
be
be
done.
done.
I
I
just
just
want
want
to
to
show
show
you
you
guys.
guys.
Give me one second. So
So
for the
for the
optimizing
optimizing,
with the blend radius part and things like that that I said that will be fast. One thing that you can do is put, for example, like Pete said in the beginning, instead of going with the move L, I left it for the last because this is one of the options to make your program go faster. Instead of making it move L, go up, stop, go to the left to the other side, and stop, you can put a move P in there, or you can put a blend radius in there. And by putting that blend radius in there, it won't stop at that second point. It will just go passing through it, and that will give you at least 2-3 seconds more time that the program will be a little bit more efficient. Um, Another thing that the robot can do too is you can play with the speeds of the moves. So if you have a move J, you can change the speed of it. But um, they rather, a lot of times they tell you they rather have you working with the blend options and combination of move P's and other moves than changing your speed of the move itself, because a lot of times if you move if you, let's say you have a move L, and in our program we have a move L that has two waypoints in it because it's going down and coming up. So if you put a change in speed for that move L, it will change the speed for both of the waypoints. So if you're not cautious, you can move the speed of one move. You can change the speed of one move, but then you can be making damages on the waypoints in it. So it's very important to make sure that if you're changing speeds, just change them in the waypoint itself. If you do, or if you want to move, if you want to change the speed in the motions, in the moves, make sure that all the moves and all the waypoints in that move are supposed to go into that speed, because otherwise you're going to have that the robot's going to go up, come down, and when it moves it's going to hit things. Because put the robot to move faster, make it moving faster, that's going to be working on your joints and things like that too. So your maintenance is going to be services and things like that is going to be it's going to be faster. So that's another thing that they rather not have you do that. And that's it for me, guys. Like I said, I tried to hold it at 1 hour and a half. There's a lot more to it. That's like moving planes. You can do for packaging. You can do, for example, let it scan a certain pattern that is put. Like if you got 9 products to put, it will be in a certain pattern, and then move that pattern to another location and do the same thing. All those things you can do with it, but it's so much. There's so much behind it. And if you guys don't have any more questions, I think that'll be it for today.
Thanks, Shanita.
All right, thank you, Shanita.
Welcome.
Yeah, and Shanita, if we can just do the same thing, we can put this on OpenCam. We'll put it on the YouTube, and just let you know you had 44 to 45 views on your last one, and we shared it out to the kiddies. So they're definitely watching it. Yep.
Okay. Okay.
Yeah.
Cool.
You're gonna be a celebrity by the end of this.
No, that's not. No. That's a little bit too much.
All right, guys. Well, thank you for the presentation.
Oh, you're welcome. I'll see you guys Monday then, I guess.
Okay.
Okay, bye bye. I gotta stop.